Mendez, and I'm in the mechatronics program at Penn College.
Okay, and you are?
I'm Zach Barrett, and I'm in the robotics major.
Okay, cool. And what's your project here?
Well, this is it's a ceramic heating element. Okay, and then we have a fan on the back. Okay, so what this does is this box will heat up, and then we pull in ambient temperature air from these 4 holes over here, and then we use this fan to pull the air out. So we have hot air coming out, and then ambient temperature air coming in, and that's just to keep the element at a constant temperature. And we have PLCs back here and a temperature sensor inside to help us figure out our temperature, and then
So that little wire coming down, that's the temperature sensor, right? Yeah.
Yep.
Okay.
RTD.
Okay.
Temperature device.
Okay, cool.
and then he did the programming part.
And so
How's it work?
the RTD measures the difference in resistance based off of the heat in the box, and it gives me a set of numbers, which is the raw data, and then I take the raw data and convert it into a visual temperature.
Can you describe this program here? This is the RS Logic
Yeah, 5,000.
5000. Okay, so this is a ladder logic.
Ladder
program
logic.
you're running. Okay,
Correct.
cool.
So I take that temperature in Fahrenheit and I convert it also into Celsius.
Yeah.
And then this is my, from here down is my area of how to operate the fan and turning on the light, or the heating element on and off.
Okay, so right now it says fan off is true and light is true.
Correct. So my temperature set points are at the lowest at 90 degrees Fahrenheit, and my high is 95 degrees Fahrenheit, which is seen right there. And so this is my HMI screen. I'm trending both data for Fahrenheit and Celsius over a period of time. So so whenever it hits 95 degrees, the heating element turns off, my fan turns on, pulling the hot air out and cool air in, and then the fan continues to run until it hits 90 degrees, in which the fan turns off and the heating element will turn back on.
So can you increase the heating and go quicker by covering these holes maybe?
Yeah, you can see it over time.
So it's rising pretty fast. So the fan's not on now. So right. So
Correct.
as soon as it heats up to 95, let's see if we can catch it here. The fan should come on, right? So here's the fan. Now there's no light on the ceramic heater because it's just a resistive heat,
Correct.
right? And so we're at 94.79 and 86. Oh, and there it's kicking on. Okay, I'm going to take my hand away. So now, when does the fan shut off again?
90 degrees.
At 90 degrees. Okay.
So you can see every second it updates the trending graph.
Now, how did you design this screen here? Is this the Wonderware?
No, this is Factory Talk.
Factory
View.
Talk. Okay. Interesting. So it's dropping and fan's still running. So what kind of fan? Is this a DC fan or an AC fan?
This is DC,
DC.
12 volt DC.
Do you have a relay that this runs
Yeah, there's a
off of?
relay in the back.
And that's for the...
Okay, so that relay there's for the fan?
No, that is
No.
for
The ceramic light. Or the ceramic heater, I mean.
Right.
Ceramic heater, okay. But the motor is just straight DC, right?
Correct.
Is that just directly off a PLC output, or do you have to run it
Directly off this power supply right here.
on the power supply?
Right.
Okay.
So
But
that's
you have to switch that, right? Somewhere.
correct. So I just hooked it from 12 volts straight to my input.
Oh, for your common on your PLC.
My output.
Right. So the PLC can provide enough current for for the fan.
Yeah.
You didn't have to use a relay. Okay. So we're getting close here, right? 92.1307. Get there. So how long did it take you to put this project together?
About 3 weeks.
3 weeks? Yeah.
It took us about a week to build the box.
Yeah.
Finding all the components and learning about everything as far as programming. It took about 2 weeks.
Right. So, but you have to make sure that the ceramic heater was going to heat up high enough to
Yeah.
hit your top high limit.
Did a
We
trial
started off
there.
with a halogen bulb,
Okay.
75 watt, but that just didn't get hot enough.
Not hot enough.
So
Okay. How many watts is this ceramic heater?
that's 150.
150, and this is only 60. So
It's a 75, yeah.
or 75. Okay.
Replaces.
Right. Well, it's actually 60 is the amount of energy, but
Oh,
75 is the
Yeah,
replacement.
yeah, you're right.
But 60 is what determines the amount of heat, the 60 watt. So we're getting pretty close. Should be a few seconds here. The fan should shut off. Now, did you try just put some ice cubes here or something to see how?
Yeah, we wanted
Quick.
to try something similar to like a cooling coil.
Yeah.
But it was just kind of difficult to find something like that. We were thinking about doing like ice pack or something like that, but it was just gonna cool off too quickly.
Yeah.
A lot of heat. So.
Now, how hard it would be to change these ranges? You could just reprogram the limits, right?
Yeah, very easily. Just go in.
If you wanted to work this to be a faster demo, you could just make the ranges tighter. Oh, did it cut off?
Yep, it just so the relay for the light turned off, or the heating element turned off, and the fan turned off. I mean the heating element turned on.
Right.
The fan turned off.
And now it's heating again.
Correct.
Yeah. All right. Cool. All right. Good job, you guys.